Okay, so this is what we up to. Okay, so on this video, we're going to continue with the Pascal triangle and binomial expansions. Okay, that's what we did yesterday. Yesterday we said this. So we say if A and B are real numbers and N is a natural number or 0, so that means that N is a non-negative whole number, then we can prove that A plus B to the power of N, so the expansion of A plus B to the power of M is going to be equal to the sum from R equal 0 to N of what? Of these terms. Okay, so that is what we said yesterday, right? And I said to you that we're going to be proving this later when we're doing mathematical induction, all right? But for now, we're just going to use it, and then this makes a lot of sense with the expansion that we did yesterday. Remember that we have the bracket, we have the power, and then we have a sum of a number of terms. Okay, so that is what we are saying here. Okay, so nothing more than that. Okay, so we're going to do some application of this, a very simple application, and then we're going to study some important properties of the Pascal triangle. Okay, can you see that the Pascal triangle look very, very symmetrical when you draw it? It's very, very symmetrical. Hello. Okay, so here we go. So we're going to say application. Right. Okay, so like I said, we're going to start with the easy one. By the way, the video from the the introduction of this will be available. So if for some reason you were away, you can go to my YouTube channel and watch it. Okay, so everything that we did yesterday will be there. Okay, so application. Expand each binomial. Okay, now that we know the sort of formula, we can do expansion with big powers. So we know how to do, p plus q in bracket square. And yesterday we went through, the easy question. Okay, but I really want to have a go again with the easy one, because I really want you to get very, very familiar with this notation. And then we're going to move on to some of the property, and then we're going to do some more complex question. Okay, so we got that one. Okay, so p plus q square, and then x plus y to the power of 3, and then a plus b to the power of 5, and we're going to have also d 4 plus x to the power of 5, e is 3x minus 2 to the power of 4. And then, question F, say if 1 plus square root of 3 to the power of 4 is equal to a plus b square root of 3, then the question is find the value of A, B. Okay, so this question. Right. Okay, so we're going to let you copy this, and then we're going to go through this, okay? And if you're running a little bit behind, you can take a photo with your mobile phone, okay? And then you can copy the rest. All right, so here we go. So we're going to say solution. Now, what we are going to do, we are going to use this to do this one, all right? Step by step. We already know how to do this in the old-fashioned way, okay? But I really want you to get familiar with this notation. Okay, so we're going to say solution. Question A is P plus Q square. All right. And we're going to write exactly what we have in here. So we're going to say this is the sum from R equal 0 to 2, okay, n in this case equal to 2. Can you see that? Yes? And then the binomial coefficient, so it's going to be 2R, and then we're going to say P is going to be 2 minus R, and then Q R. Okay, so all what I did is just substitute this number in the formula. Okay? All right, that's all what we have done. So I'm going to wait for you to copy this. All right, now we're going to expand this. Okay, so in here they say that we're going to go from 0 to 2. So from 0, and then we're going to stop at 2. And this is how we do it. So we're going to start from 2. Remember, by the way, you don't need to copy this, but you got to remember that N R, like this, is the same as NCR. All right, did you remember? Okay, so we're going to be using this notation and that notation, you know, all the time. Now I need my duster. Yeah. Yeah, but it gets too bright, and then I have a problem with the camera. I need to fix that. Okay, anyways, here we go. So we always start with 2, and then the first number is 0. So we're going to say 2, 0, like that. And then we're going to put P, and then 2 minus 0, and then Q to the power of 0. Okay, so that's going to be the first term. And again, all what I'm doing is just substituting. Okay, so we start from 0. Now we're going to 1. So we're going to say plus 2, 1, and then P. So it's going to be 2 minus 1, and then Q 1. All right? Substitution again. And then we have 2, 2, and then we're going to have P 2 minus 2, and then we're going to finish with Q square. All right? So that was substitution. And then we're going to simplify. And we know already that the answer is going to be P squared plus 2P plus Q squared, right? I guess so that is very well known. Okay. So if you put this in your calculator, so if you do 2C0, You can put that in your calculator. 2C0. You're going to see that the answer is equal to 1. All right? So it's going to be equal to 1. And then p squared minus 0 is just p squared. So we're going to say p squared. And then q to the power of 0 is just 1. So that means that the first term is p squared. That's it. Okay? Now, let's do the next one. So we've done the first term. Let's do the second term. Okay, the second term is going to be 2c1. So if you do 2c1 in your calculator, the answer is going to be 2. Okay? It's going to be 2. And then in here we have p to the power of 2 minus 1, so it's going to be just p. And then q to the power of 1, which is just q. And guess what I mean? It's looking so much like, well, we know. Again, the last one. And then I want you to do 2c2. So that is going to be equal to 1. All right? And then you can see that we have p to the power of 2 minus 2, or p to the power of 0, which is equal to 1. And then we have q squared. So that means that the answer is going to be just q squared. I guess that's exactly what we knew from the beginning. All right? So that means that the formula is working. All right, let's do the other one. Question B. So we need to do a few of these until you get very, very familiar with this. Okay? All right, so here we are. So we have x plus y to the power of 3 now. Okay, x plus y to the power of 3. Okay, we're going to set up the formula. So we're going to say this is the sum from r equal 0 to 3. And then the binomial coefficient, so it's going to be 3r. Okay. And then we're going to say, well, x is 3 minus r is always the top number, take away the bottom number. And then y to the power of the bottom number. Okay? That's it. That's how you set up the formula, and then we're going to expand it. Right? Okay, so here we go. Okay, the first one, you're going to tell me. Okay, who wants to tell me what is the first term? All right, go for it.
Wait, like the first was in like p squared, or is in like 3 over 0?
Yeah, so it's 3, 0.
0.
So I'll say 3, 0, step by step, and then?
And then it would be x3 minus 0.
Yeah, 3 minus 0, why not?
And then y to the power of 0.
Y to the power of 0. All right, so that is the first term. Okay, who wants to do the second one?
Amelia.
3, 1.
3, 1.
X to the power of 3 minus 1.
So x to the power of 3 minus 1.
And then y.
Y to the power of 1. Okay, so this number matches always the power of the second polynomial. And then, all right, who's going to do the next one?
Sure. So
All right.
3 and 2.
Mm-hmm.
And then you've got x to the power of 3 minus 2. And y to the power of 2.
Yes. Okay, so when you have this, or when we use this notation, we normally say 3 take 0, and here we say 3 takes 1. Remember that when we do the 3C2, we're talking about having 3 and taking 2. Okay, so that is what we normally say. Here we say 3 take 0, 3 take 1. So I mean that for the next one, which is say 3 take 3, or you can say 3C3 is the same thing. Okay, and then Ella, what should I put in here?
X to the power of 3 minus
Mm-hmm.
and y to the power of 3.
Yeah, perfect. Okay, and then we're going to simplify each term. And let's see what happens. Okay, so if you simplify the first term, then the answer is going to be just x to the power of 3, okay? At this point, you should notice that, 3c0 or anything 0 will give you 1, okay? So that is something that we're going to have to mention later when doing the properties. Okay, the next one. For the next one, we're going to have 3c1 or 3k1, and that will give you 3. Okay, so that's going to be 3. And then you're going to have x squared, and then the first y will appear. Okay, so we're going to have y there. Right? And then the next one, so plus 3c2. Okay, 3c2 or 3k2 is going to be equal to 3 again. It's going to be 3. But then the power of x will decrease to 1, and the power of y will increase to 2. Right? And then finally, when these two numbers are the same, then the answer is 1. Okay, so I mean that this is 1, and then we're going to have x to the power of 0, so we're not going to write that down, but we're going to put the y there. Okay, and that is what we did yesterday. Okay, when we did the expansion and simplify, we got this result. And again, you can see the symmetry. So we got 1, 3, 3, 1. Okay, so here we have the 1, 2, 1. So always you're going to have a symmetry. Okay, that's why we have, that beautiful tree or triangle. Okay, so the next one. Can I write this off? Mm-hmm. Yeah? All right. Okay, so we're up to questions C. Right. Question C. So we're going to say A plus B to the power of 5. Okay, step number 1, we're going to set up the formula. So I say that is the sum from R equal 0 to 5. And then this time I'm going to be using the C notation, okay, just to do something different. So we're going to say phi C R, and then we're going to put A phi minus R B R. Right. Okay, Anna, you're going to help me with this one.
So the first term is 5c0
Mm-hmm.
x 5 minus to the power of 5 minus 0.
A? A?
A, yeah, sorry. Same thing.
A to the power of 5 minus 0.
And b to the power of 0.
Now, I want you to see the pattern. Can you see that the first polynomial, or the power from the first polynomial is always equal to that number, take away that number? And can you see that the power of the second polynomial, in this case, is always equal to that one? Okay, so this number matches that one, and this minus that is the power of the first one. Okay, so I mean that the next one is going to be phi C1. Okay, and then we're going to have A phi minus 1, and then B 1. Okay, being consistent with what I just said. Yeah. Sure. Okay, and then we're going to have phi C2 A to to the power of 5 minus 2, u squared, and so on. Okay, Archie?
Yeah.
All right, the next one, I'm going to continue here, so it's going to be plus 5c3, a 5 minus 3, and so on. And then when we stop, when we have same number at the top and also at the bottom, so we have a 5 minus 5, b 5. Right. Again, then we're going to simplify. So we know that the first one is going to be a to the power of 5. Okay, so we know that the first one is going to be just a to the power of 5. And the next one, so it's going to be 5c1, that will give you 5. So we're going to have 5 a to the power of 4b. Okay, the next one, 5c2. What is the answer 5c2?
10.
Okay, so let's say 10 a to the power of 3 now, but b goes up, so it's square. And then the next one, 5c3. What's the answer 5c3?
10.
10. So we're going to have 10 a square b cubed. Okay, and then we have 5c4. What's the answer 5c4?
5.
So it's going to be 5 a b. And finally,
B power of 5.
that's it. Okay. You see, as I said to you yesterday, now you can do any expansion very, very easy, and you have a very systematical way of doing it. Okay, so it's very, very good. Okay, so now you're going to do question D, and then we'll check the answer.
Oh, yeah.
Right.
Check the answer. Oh.
Okay, I'm going to set up the formula for you, but then you're going to do the expansion and tell me what the final answer is. Okay. So go for it. You're going to simplify. Yeah, so you're going to simplify. So if you have 4 to the power of 5, you're going to actually simplify. Okay, by now you should know what the answer is, all right? Dan, Ashton, can you please tell me what the answer is?
Got 1,024.
What is it?
1,024
1,024
plus 1,280x.
1,280,
Yeah,
and then
x
x, yeah,
plus 640x squared
x square,
plus 160x cubed
and then
plus 20x to the power 4 and then plus x to the power 5.
x to the power 5. Okay, that's it. Okay, so this time we have, a more numerical solution. Okay, but still it's coming from the main formula. Okay, so that was okay. Now, in the same way, I want you to do question E, and I want you to give me the simplest form. Okay, so you're going to simplify, all right? Okay, so I'm going to delete this.